All right, so this is number 16 on quad 10. You have a 1,200-foot roll of fencing in a large field. You want to make two paddocks, so for instance, a pen for two animals, like maybe chickens and ducks, by splitting the rectangle enclosure in half. What are the dimensions of the largest such enclosure? All right, so let's take a look at this. So first of all, if you have a little picture here, you've got some sort of a enclosure, and you want to cut it in half. So once again, in a word problem, you want to define your variables. So I'm going to say x equals width. You could just as easily have said x equals length. It doesn't really matter. And I'm going to say y equals area. Well, if I'm setting x equal to width, that means this will be x, this will be x, and this will be x. Now, had you said x equals length, then you just would have said this is x and this is x. It's not going to affect the outcome of the problem. Your equation will be a little different, but your answer won't change. All right. Well, I have 1,200 total feet of fencing. That's what I have. But I've already used up x, x, and x. So I've already used up 3x worth of fencing. So what I have left is 1,200 minus 3x. That's how much fencing I have available. But I have to put that fencing here and here. So there's two places I have to put that fencing. So if I want to find an expression for just this length, I have to divide that by 2. So I know that this is going to be 600 minus 3 over 2x. That's what this length would be. And this length would also be 600 minus 3 over 2x. So now I have all of my variables. I've set y equal to area. So if I want to know the area of this rectangle, I have to take my length times my width. So I'm going to say area equals my width times my length. And I'm going to put this in my calculator. So I'm going to change that 3 over 2 to 1.5 because it'll be easier to put it in my calculator. Now, you could multiply this out, and then you could use the minus b over 2a to find the maximum. That would be absolutely fine. But I'm going to graph this. So let's go to our calculator. All right. So the first thing you want to do is go to your y editor, and you're going to put your equation in. So x times 600 minus 1.5x. All right. And now you're going to graph it. All right. Well, you can kind of see this blue on the bottom. That's not a very good graph. So let's go to our window. And I'm going to change this to, I don't know, maybe 100. And I'm going to change this y max to 20,000. And again, it's really just a guess. And I'm going to hit graph and see what I have. All right. So now I can see by looking at this graph that this probably comes up and around and down like this. So I'm going to need a lot more x's and a lot more y's. So let's go ahead and try our window. Let's go up to, I don't know, let's go up to 500 on my x's. And let's go up to 50,000 on my y's. And hit graph again. All right, so now I have a little bit of a better window. I can see where my parabola ends on the x-axis, but I can't see my my vertex, so I'm going to have to add some more y's. So let's go down. Let's just change this. Whoops. Let's change this to 80. Just, again, arbitrary. You may have chose 70 and it would have been fine. Whoops, I have one too many zeros here. All right, now that looks like a pretty good parabola. So now that I have a good parabola, I'm going to draw this on my paper, right? Because since I used my calculator, my graph is part of my answer. And you just have to do it roughly, right? I started at 0 because it's a word problem, so negatives don't mean anything. So I'm always going to start at my x's and y's at 0. On this axis, I think I went to 500. And here I went to 80,000. And again, it's a word problem, so I want to make sure I label my graph. So my x's were width, and my y's were area. There, so now I have a nice little graph. So now I have to go back and I want to find the vertex. So I'm going to go to second trace or calc, And I want to find the maximum, so I'm going to go to number 4. It says left bound, so I'm going to put my cursor to the left of my vertex, anywhere to the left. It doesn't really matter. I'm going to hit enter. And now I'm going to go to the right of my vertex and hit enter. And then it says guess, so I'm just going to hit enter again. And it tells me that my vertex is 200, if I round that, and 60,000. So now what this tells me is my x is 2,000 and my y is 60,000. So I know that the maximum area would be 60,000, and I know that my x is 2,000. But let's go back and find out, well, what did the question actually ask? Well, the question asked, what are the dimensions of the largest enclosure? So my dimensions, remember my x is width, so I know that this is 200. And if I substitute 200 in for here, I'll have what my width is. And you'll find out that the answer is that the largest such enclosure would be 200 feet by 300 feet. And that's your solution.